Okay, in this video, we're going to try to add processor control to the blink rate. So one of the RISC processors and the MSS will be able to change the blink rate and make it blink faster or slower by doing writes over the APB bus, the AMBA Advanced Peripheral Bus. Yeah, APB. So this is just a basic standard blinky every clock edge. If the reset's set, if the reset is asserted, then we clear it. Otherwise, the reset's not asserted. The count's gonna count when it's less than blink rate, which is gonna be programmable. And when it gets to blink rate, it wraps back to zero. So it keeps counting at zero to count to blink rate, wrap. Every time it wraps, so whenever it equals a 1, then the LED is going, the LED output, which drives the output of the FPGA, which drives the LED, will blink high, low, high, low, high, low, high, low. All right. The APB bus is here. It's pretty straightforward. When these signals are high, whatever's on the data bus gets written into our register. And that when this address is 4, so the address has to be a 4. Here is when we're not there. When the address is a 4, we will put whatever's on blink rate onto the data bus. Yeah, it'll always be ready, and there'll never be an error. All right. So we went, we boom, did a control C, went over to our virtual machine, and we pasted it into APB BeagleV. So here it is pasted. No changes to it. Control Q. Now nonetheless, there is also, I noticed, the APB control status bus, status register block. Pretty much does the same thing that we wanted to do, and it lives off the APB bus. Slightly different address, so I think they can work almost in harmony. So now what we're going to do is instantiate this guy into the cape. So let's edit this guy and the cape. Let's go to this guy. Just let's do it this way so everyone can see what's going on. So I select it, copy, Control G, go back to cape, Control the underscore, Control. So there's the status register. Here's what we want. To be honest with you, I think it's probably the easiest to just take what he had, what the original had, copy, and just steal it. Not above that. Paste. Right. And then what we want to do is change this guy. APB Blinky. Yeah. Change this guy. APB Blinky underscore 0 because it's just a protocol. It's just a convention that these people are following, is to put a number after this, after the instance name. All of these remain the same. And instead of control, we have LED. And here we have Blinky 2. And just give you flavor. Oh, interesting. Blink. Oh, blink two. And so blink two is something we've added in a previous demo. Control D. So let's find it. Mm, So it's just a wire. So make it this. It won't be in any. I guess if you downloaded my serve cape, it would be. So I'd recommend starting there. DF. Blink 2, I put it into the output list of nets, and I made this output E here. Instead of a 1-tick B1, I made it a 2-tick B11. So that makes it an output. And so Blink will be controlled by our serve processor done from a previous demo. And Blink 2 will be output of this hardware blinking. Okay. And now then, we've got this R data. Interesting. Um, I'm going to do two things here. One of them, so we have two blocks. So we got a wire 31:0, so it's a 32-bit word. And we're going to call him, it could be status underscore R data XV of this guy. We're going to call him APP Linky R data. Nice, right? And we're going to go to here, D, and APP Blinky R data. Up in here, okay. DC, we don't want to lose this guy. So we'll come back to him in just a moment. Let's finish the edit up here. D. Okay, so each one of these blocks has some returns some read data. And we made it so that so we assign it to the read data from this block or the read data from this block. Reason we can get away with the or is that this block here always drives the read data bus to 0. Well, this is the default case, so it's always driving the read data bus to 0, except for when the address is the status control was 0 or control 1. And so they had status at 20, 10, and 0. So every other address of this block is driving 0. In Blinky, we've got it where we just have one register when the address, lowest byte of the address is a 4, then we're driving it. Otherwise, we drive it to 0. So, scratch. So we can get away with either we're driving it to this or this. This is a bitwise or. Hope that kind of made sense. Well, get rid of this. We don't need any of this. Okay, so this is going to be the first part. We're going to do a Control S. Remember this. Control Q. All right, so now there's some sort of cd dot pwd ls and edit add cape. And in add cape, what we want to do is let's see, it's right, pop it right here next to its buddy. So we add right here. Okay, so we got add Blinky. Now, in the list of Verilog files, HDL source files, that will get compiled into the cape. Do that. Good, good, good. So Control S a few times. Phew. I believe that should be all we have to do on the build side to make that blinky work. And let's see what we can do. So git status. Git. Right. So we changed add cape. We changed cape, and we added a new file called add blinky, app blinky. Okay. Git status. Git commit. Git log. I like to follow the format that people want for it. So git commit add app blinky add address 4. It's not bad. Okay, hit return. Okay, now we do git push. All right, so that should be pushed. So we can somehow get to our. How do we get to our? Let's see, I had a bookmark. Did we get lab? Here we go. Let's go to Gateware serve, which is where I'm building. And let's go to build, hover over build, slide over to pipelines. Sometimes you have to click on builds, go down to pipeline. It's running. Hopefully that should be all we need to play with having the processor read and write to it. Okay, in the previous video, we poked around with Libro, and we found out that the cape was located at address 41xxxxxx. So the top the top byte is a 41, and then the other bytes are whatever your address decode wants to be. So we figured that out right, then we should be able to put that into a little blinky file. So let's see if we can do that. Okay, so that would be done by I think we gotta plug in our let's see. Okay, we just plugged in our Beagle. Go to Dev Mice Manager. Reports, and wait for a port to come alive here. In the meantime, we can also get Putty ready. Putty. Okay. And it'll be a serial port. My bet is a 19. That's what's been coming up lately. And then 115, 200 for the speed. And here it comes. Wait for it. Wait for it. Dev column 19. Great. Okay. So let's open. Let's make him a little bit bigger. And log in with Beagle. Here's the right here. They print out the username and password. So Beagle is the username, and you can read the password. Okay. PWD. Okay, here we are, LS. And so we have the hello.c program that we already wrote. Let's copy that. Copy hello to blinky.c. I have no idea if this is going to work. I've never been on this side of the world with Linux. I've done it on bare metal hardware, but never on Linux. So hoping this works. Oops, my happy editor's not there. Okay. All right, so that's nice. Okay, so what I'm going to do is I'm going to say I, and then we're going to evolve file. Um, I think before that, volatile uint 32 t. Um, yeah, let's keep it simple. Int um, uh, pointer to an int is a so I really want a uint32 there, but I'm just going to go with int for now. Int, what do we call it? Blinky adder equals int pointer. How do you do it? OX 41. Oh, 1, 2, 3, 4. All right. This is my Blinky wanted to be at address 4. All right. So what are we gonna do? What are we gonna do? What are we gonna do? Um, I guess we're gonna do a contents linky adder equals some value. What value do we want? I'm trying to make a useful demo. Um, let's go back to our Verilog code and look at it. And let's see, HDL. Okay, that is Blinky. So let's take a look at this value. Copy. All right, now let's go back to putty. Back to our. Why do we have two putties? Why do we have two putties? Okay, this interactive. So that must have been the previous time I was playing. Okay, I'll edit. Okay, so we got this guy here. So that's 100,000. So this is kind of like in a previous demo on with Libero, just the one before this, we found out that the clock is running at 50 megahertz, and we also found out that the address of the cape is at OX 41000000, and then along with an offset, and our offset in our case is 4. So that's how we got that. 100,000 would mean it's blinking. About 50 megahertz clock. This is 100 megahertz. So it's probably going to blink every 2 seconds. So let's change that to make it blink much faster. So there we go. It's going to blink 10 times faster. So if it's a rapid blink, the right worked. If it's not a rapid blink, then the right did not work. And now then also we're going to go in and say int um, response equals star Blinky adder. So the contents of Blinky adder. And then we're going to do print f Response equals %d, comma. Who likes that? Does that look good? Response, let's say a carriage return. And I think we're here, so turn 0. All right, how's that for a C program? Hello. Write a 10, which I believe will be a fast blink rate, and a response is this, and yeah, it's good to go. Okay, so let's see, control, how do you get out of, what am I in? Vim, control Q. Let's see, no, not control Q. Shift colon right W Q, quit, return. Okay, so let's see if we actually got what we wanted. Blinky.fc. All right, let's compile this while we wait for the synthesis to run. So we should be able to do what? GCC Blinky. Return. It's mad about something. Stupid. I left in the spaces. All right. X, X. Right. Shift colon WQ. Let's see, GCC again. Blink adder. It looks like some sort of typo there, so let's take a look. It's probably Blinky adder. It's the error message. Q. Blink adder. Blink adder. Blinky adder. Why couldn't I see that? Hold on. Okay, so we got Blinky adder here, Blinky adder here. Oh, that's why we couldn't look at the wrong line. I, Y, escape, colon, WQ, cat. Hello, cat. Cat, Blinkies, let's see. So that looks about what we want. And GCC, Blinky, let's see. Okay, ls dash L. And let's see, what I like to do is ls-LTR, which sorts by time and puts the most recent one just above them. So right here's the most recent one. It says it happened at midnight, which is the wrong time, but I can live with that. It's just after when we edited Blinky. All right. What happens if we do 8 out out? Hopefully it comes back. Seg fault. Ooh, seg fault. Ooh. Segfault. Ooh. So that's not good. All right. Well, that's not good either. Uh, So we got a lot of work to do here. Download, all right, build, archive. All right, go over to here. Explorer 743. I think we're about to stop here. Downloads. Um, delete these. Extract all. And what are we looking for? Something. Okay. Edit real bad. Yes. Stuff. Board. Control F E R R. Okay. Fine. Try next. C log file. An SRR. All right, so I'm going to have to build this on my own Libero. Wrapping it up for now.